Hi everyone, Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my series of videos on calculus, and we're going to answer the question, how can I use calculus to compute surface area? So I'll step you through an example, and then I'll show you where the formula comes from in a very broad and loose sense. So let me share my screen with you, and we can get down to business. Okay, here is the example. We've got a function, and the curve associated with that function on this interval is rotated about the x-axis. We're asked to compute the surface area of the resulting solid. So I'm going to quickly draw a very simple sketch here to give us some idea of what's going on. Okay, so let's look at, say, the square root function. We rotate that bit, so that'll be 4 there. We rotate that bit around the x-axis, and we'll get a solid. Looks a bit like a cone with sort of curved sides, if you like. And the question is, what is the surface area, not including the top, just the surface area of that solid? So how do we do it? Well, we use calculus, and in particular, we're going to use integration. So let me show you. Okay, so I'll come back to this picture in a minute, but to apply the formula, let's call the surface area SA, just for surface area. Now, the formula is the following. Given a function, f of x, that's rotated about the x-axis, the formula for the surface area of the solid is this. Now, alpha would, in this case, would correspond to the 0, beta would correspond to the 4, f of x would correspond to square root x, and this is the derivative. F dash is the derivative, so if we differentiate this, we get 1 on 2 root x, and then you would just use this and integrate. Okay, now the question is, where does this come from? I'll get to that at the end of the presentation, but let's just go through and knock this out. So, all right, so f of x is that. If I differentiate root x, think of it as x to the half. The half comes to the front when you differentiate it, and you decrease the power by 1, so you get a half x to the negative half, which is just 1 on 2 root x. So let's put this in. So I get 2 pi root x times 1 plus, okay, and the derivative is 1 on 2 root x all squared dx. Okay, now this looks a little bit messy here. Let's square this to get rid of that square root sign, and then we'll combine the square root signs just using the index or the power, the index laws. Okay, so here I'm going to get 1 plus 1 on 4x. Okay, and now what I can do is I can use my index laws and combine these powers of 1/2 into one expression. So the x would come in there, the x would come in there, the x's will cancel, and you'll get square root x plus 1/4. Okay. So now we're in the position where we can compute the integral now. Okay, there's a little bit of work to try to simplify it, and that's usually pretty standard with these problems. So let's actually knock over the integral now. Okay, well, this is a linear expression in here. The coefficient of x is 1. Think of the square root again as a power of 1/2. The 2 pi, well, that can come to the front. That doesn't change anything with respect to the actual integration. So if I was to integrate this, I would get the power 1/2, the square root sign would become, you increase that by 1, so it becomes 3/2, and you divide by the new power. That's the same as multiplying by its reciprocal. Now, if you're not sure how I went from here to here, what you can do is, if you really want to, you can use a u substitution. Let u equal x plus 1/4. Okay, but you really shouldn't have to do that. Okay, so now the last thing is to put in the numbers, right? So we have, so the 2 on 3 can come to the front, so that'll be 4 pi on 3. And let's put in the numbers. So I'll get 4 plus 1/4 minus, you replace x with 0, so you get 1/4 to the 3 on 2. Okay, so this will give you 17 on 4 to the 3 on 2 minus 1/4 to the 3 on 2. And now it's just a matter of cleaning it up, okay? So if you take 4 to the power 3 on 2, that's square root of 4 cubed. So 4 to the power 3 on 2 is just 2 cubed, which is 8. So you're going to have an 8 down there and an 8 down there. So this whole thing will be 1 on 8. So I can bring that and simplify just a little bit more. Okay, so 4 to the 3 on 2 equals 8. And then you can cross off here, you get a pi on 6 out the front. And we're finished. Okay. All right, so that would be in square units because we're talking about surface area. So you can see the actual integration wasn't really that hard. It was more about setting up the integral and simplifying with algebra. So where does the formula come from? Let's just give a basic talk about that. So let's go back to our original picture. Okay, so this is the curve y equals root x. Let me just see if I can make that a bit darker. Y equals root x. Okay, just this half of the curve. And where does this come from? Well, let me just draw a little slice in. Okay, so I'm slicing my solid. Now, if you look at this, what does this remind you of? 2 pi f of x. Well, if you think of this as a circle, f of x, the value of y, or y equals f of x, is the radius of this cross-sectional circle. So that sort of gives you 2 pi times the radius. That's the circumference, right? If you have a circle with radius y or radius f of x, 2 pi f of x is the circumference of the circle, okay? And what's this? Well, this essentially gives you the length of that curve, okay? Like an arc length, okay? Again, I'm speaking quite loosely here. So you've got circumference and you've got arc length. So what happens is when you sum this up and take a limit, you're basically calculating all the circumferences, if you like, that go from here up to the end of the curve. And that gives you the surface area, okay? Now that is a very, very loose definition. You can relate it back to arc length if you want. It's sort of like a step up after arc length, and I have some videos on that. But let's just recap what we did. First of all, we drew a picture. A picture is great because it helps us visualize what's going on and geometrically understand what's going on. Then we applied the formula, and the biggest challenge here was actually simplifying the expression to do the integration. We did the integration, it took us a while, and then simplified, and our answer would be in units squared, okay, because we're talking about surface area. Okay, what do you think? Hope you enjoyed this video. If you have any questions, you can always post them in the comment section. And thanks for watching. Hope to see you again soon. Bye.